So this is exercise 1.2 from NCERT, and this is functions. So question number 1, show that the function f such that r star to r star defined by fx equal to 1 by x is 1 1 and on 2, where r star is the set of all non-zero real numbers. Is the result true if the domain r star is replaced by n and with the codomain being r star? Okay, so what is r star? R star is this real number minus the element 0, non-zero real numbers. Okay, so it is 1 1 and on 2, and next r star is replaced by the natural number n and codomain is r star. So you should write fx equal to, okay, sorry, at first you have to write f such that r star to r star, because I have already told that for a function the domain and range is very much important. Fx equal to 1 by x if x1 x2 belongs to r. No, this is not right. Given fx equal to 1 by x, now then let x1 comma x2 belongs to r and fx1 equal to fx2. Okay, so let then fx1 equal to fx2, that implies what is fx1? Fx1 is 1 by x1 and fx2 is 1 by x2. So multiplying this way, x2 equal to x1, or that implies x1 equal to x2. So fx1 equal to fx2 implies x1 equal to x2. That means therefore f is 1 1. Now if fx equal to, let y equal to 1 by x, then y equal to 1, and then x equal to 1 by y. Again, this is y star. So, okay, given y belongs to y star, given or x equal to 1 by y, so fx, no, not this, not like this. So y, given y belongs to r star, that implies y by 1 by y belongs to r star. So y belongs to r star means 1 by y belongs to r star also. So for all y belongs to r star, there exists a x, don't write a, only x, such that fx equal to y, and therefore f is on to function. and as fx is 1 1 and on 2, so f is 1 1 and on 2 function, that implies f is a bijective function. Now the function from n to r star, this was r star, is defined by fx equal to 1 by x, two belongs to natural number, and 2 is also not the reciprocal of any natural number. So fx equal to 2, one second, the domain r star is replaced by the natural number n, and codomain being the non-zero real numbers r star. Okay, this is incorrect. Fx1 equal to this, fx2 equal to this. If fx1 equal to fx2, then 1 by x1 equal to 1 by x2 implies x1 equal to x2. F is 1 1 function. Fx equal to 1 by x, let y equal to 1 by x, then 1 by y equal to x equal to 1 by y. No, 1 ff 1 by y equal to y. No, here you have to write that y belongs to r star, that implies 1 by y belongs to r star. So for all y belongs to r star, there exists x such that fx equal to y. Therefore f is onto function. Now n1 comma n2 belongs to natural number. Why it is r? So you have to write here that f such that, okay, r star to r star, and here 1 by x is defined because of this. We have excluded the element 0. That is why this is defined 1 by x. So n1 comma n2 belongs to natural number, 1 by n1 equal to 1 by n2. That implies, so n1 equal to n2, and both n1 n2 is from natural number, and this 1 by n1 and 1 by n2, these are real numbers. These are real numbers, or more precisely, these are from 0 to 1, right? More precise. So f is 1 1, but f is not on 2. Why f is not on 2? Why f is not on 2? That you have to show. So this f from natural number to r star, this function is 1 1 because n1 comma n2 belongs to natural number, the domain. So fx1 equal to fx2, this implies that n1 equal to n2, and therefore f is 1 1 function. But is for all y, So the question is for all y belongs to R star, because R star is the domain. You can see here R star is the domain. So is for all R y in R star, there exists x such that fx equal to y. The answer is no. That is why it is not onto. So you have to give such example. So 2 belongs to R star. For 2 belongs to R star, uh, there is one example is enough. We don't have to give uh, another example. If it is if for any y belongs to R star, there does not exist a x such that fx equal to y, then it is not onto. So for 2, for example, 2 belongs to R star, but there does not exist x belongs to natural number such that fx equal to 2, because if fx equal to 2, that implies, what is the definition of fx? 1 by x equal to 2. That implies x equal to 1 by 2. This does not belongs to natural numbers. So there does not exist. So there does not exist any natural number n such that 1 by n equal to 2. Therefore, f is not onto function. Okay.
Okay.
Have you done question number 2? Hello.
No, sir.
Praditi, can you solve it?
I'm trying. I've not done.
Okay, try. Okay, Praditi, let her do. Okay.
Okay.
So you can try the question number 3.
Okay.
So this is the box function, that is greatest integer function. Prove that the greatest integer function f such that R2 are given by fx equal to boxes is neither 1 1 nor onto, where box x denotes the greatest integer less than or equal to x. Try it. Okay.
Okay.
Question number 2. Check injectivity and surjectivity of the following functions. F from natural number to natural number n to n given by fx equal to x square. So this is question number 1. F such that from n to n and fx equal to x square. So let x1 comma x2 belongs to natural number n. Fx1 equal to fx2. This implies x1 whole square equal to x2 whole square. That implies x1 whole square minus x2 whole square equal to 0. So that implies x1 minus x2 x1 plus x2 equal to 0. That implies x1 equal to plus minus x2. Now you have to write why x minus x2 is excluded from this solution. Now x1 x2 belongs to natural number. So um, minus x2 does not belongs to natural number. uh, that is x1 equal to x2 is the only solution of fx1 equal to fx2. So that implies fx1 equal to fx2. Here you write therefore implies x1 equal to x2. That implies f is 1 1. Now on to, for ontoness, 5 belongs to natural number, but there exists no n belongs to natural number such that n square is equal to 5. That implies f is not onto map, onto function or onto map, onto function, onto map or onto mapping, all are same. And onto means surjective, it is not surjective map. Okay, so for z to z, this case fx equal to x square, because we again we will find the solution of this x square, x1 equal to x1 whole square equal to x2 whole square. This we get x1 equal to plus minus x2, and both plus minus x2 belongs to z. So fx1 equal to f minus fx1. So f is not onto. And here also 5, 7, 8 and also 6, like these numbers, and the negative numbers, negative, plus, minus, minus 1, minus 2 does not have any preimage. So you have to write this in mathematical way, mathematical language, so that the definition of the ontoness is violating. And from r to r, it is given by x square. It is not 1 1 map, and also on not onto map, because here x1 whole square equal to x2 whole square, for every x belongs to r, x1 x2 belongs to r, has two solution, that is x1 equal to plus minus x2, and for any x belongs to r, x square is greater than equal to 0. So the negative numbers, that means uh, we can write this r minus, these elements have no preimage. So this is not again onto. So write it mathematically and send it to me. Okay, I am just trying to solve this and properly solve these problems by writing and send it to me. So again, n to n, this is x cube. So here for f n to n, from natural number to natural number, fx is defined as x cube. Here x1 cube minus x2 cube, this is equal to 0. That means x1 minus x2 this, and then x1 whole square plus x1 x2 plus x2 whole square, this is equal to 0. But this cannot be 0 because this is always greater than 0, because x1 and x2 belongs to natural number and their whole square and multiplication all are positive. So this cannot be 0, this is greater than 0, so this is equal to 0. So x1 equal to x2. Again, this function is 1 1, this is 1 1 1 1 function. And for ontoness, again, the image f of n, the image is this set 1 8 27 and then 64. This is the image set, uh, which is a subset of n, proper subset. We can write this as proper subset. So f is not onto. So you have to write that there is an element that is 7 or 2 or 6 or 8 or 9, like this. These elements belongs to the natural number, but it has no pre-images. That is why it is not onto. Okay. And for z also same. For z to z, x it is x cube. So this is fx1 equal to fx2, and x1 comma x2 belongs to z. So here, so suppose x1 equal x1 cube equal to x2 cube. This is x1 minus x2 and x1 whole square into x1 x2 plus x2 whole square. This is equal to 0. Now again, this function is positive because these two are positive, and this quantity may be negative or positive. So x1 whole square plus x2 whole square is greater than x1 x2. So that means this quantity can be negative, because if x1 is less than 0 and x2 is greater than 0, then I mean, if this happen, then this quantity is negative and this is always greater than 0. That implies that x1 plus x1 whole square plus x2 whole square is greater than, always greater than x1 comma x2. And this is, so that means again this is greater than 0, so this is equal to 0. That means x1 equal to x2. That means this f such that z to z, fx equal to x cube, this is 1 1. And here also the same argument for what we have used for the natural numbers, why it is not onto, it is carried over for z. Same problem, that minus, okay, sorry, here minus 1 has, minus 1 whole cube is equal to minus 1. Again, not all the negative numbers cannot be in any numbers cube. It is not true, because minus 1 and minus 8 minus 27 minus 64, these are the cubes of minus 2 cube, minus 3 cube and minus 4 cube. So here also 2 3 4 and plus minus 2 plus minus 3 plus minus 4 plus minus 5 plus minus 6 plus minus 7 9 plus minus 8 plus minus 7, these are the numbers which and dot dot which has no preimage. That implies f is not onto onto map. Okay, so write it properly and send to me. Okay, now question
Okay.
number 3, prove that the greatest integer function f r2r given by fx equal to box x is neither 1 1 nor onto, where box x denotes the greatest integer less than or equal to x. So when we are proving that a function is not 1 1 and not onto, so take an example. So let x1 equal to 1.5 and x2 equal to 1.6. So x1 not equal to x2, but fx1 equal to 1, that is also equal to fx2. Therefore fx1 equal to fx2 does not implies x1 equal to x2. Or here we will write the reverse part. X1 not equal to x2 implies fx1 equal to fx2. So that implies f is not 1 1 1 1 map. And again, so box x, so fx is equal to box x. This f of r for x belongs to real numbers. F of r is precisely the set of integers. F of r is what? F of r is z, and z is a proper subset of r. So that implies f is not onto map. Okay.
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 Okay, so try other problems, and if you can't do, I will solve next day. Okay, so ठीक.
Okay.
So that's it for today. And the inverse function and the composition of function, because if we try to understand the inverse function, then we have to learn about compositions of function, and compositions of function and inverse function both are not present in CBSE syllabus, but it is in ISC syllabus. Though I will recommend a CBSE student to learn these things because it will be helpful for your JEE exam. Okay, Pratiti?
Okay.
Okay.